on this 2010 through 2017 Honda Accord with the 2. For gas engine, P0113 points to an intake air temperature sensor circuit high voltage condition. In plain terms, the PCM may be seeing the IAT signal higher than expected. The car may run normally, or it can have drivability changes depending on when the fault is active. Possible fault areas can include the MAF sensor and IAT sensor assembly, connector terminals, the TA and SG2 wiring, PCM software, or the PCM side of the circuit. Before touching the circuit, save the freeze data and any onboard snapshot, then start with the basic system checks. Start by verifying the problem. Turn the ignition switch to on Roman 2 or use the engine start/stop button to select on mode. With the HDS, look at IAT sensor 2. If it is more than 492V, the fault is duplicated and you keep going. If it is not more than 492V, treat it as an intermittent at this point. The system is okay right now, so check for poor connections or loose terminals at the MAF sensor/IAT sensor and at the PCM. Next, turn the ignition OFF. Disconnect the MAF sensor/IAT sensor 5P connector. Install a jumper wire between terminal No. 4, the YEL wire, and terminal No. 5, the GRY wire. Then turn the ignition back on and watch IAT sensor 2 again with the HDS. If the reading is still more than 492V, move on to checking the TA and SG2 sides of the circuit. If it is not more than 492V with that jumper in place, replace the MAF sensor/IAT sensor, then verify the repair. Now turn the ignition OFF and remove the jumper wire. Turn the ignition back on. With the MAF sensor/IAT sensor 5P connector still disconnected, measure voltage on the TA circuit between connector No. 4, the YEL wire, and body ground. You are looking for about 50V. If about 50V is there, go check the SG2 wire for an open. If about 50V is not there, go check the TA wire for an open. For the SG2 open check, turn the ignition OFF. Jump the SCS line with the HDS, then disconnect PCM connector C, the 51P connector. Check continuity on the SG2 circuit between the MAF sensor/IAT sensor 5P connector No. 5 GRY wire and PCM connector C No. 31 GRY wire. If you have continuity, the SG2 wire is okay. At that point, update the PCM if it does not have the latest software, or substitute a known good PCM. Then verify the repair. If there is no continuity, repair the open in the SG2 wire between PCM C31 and the MAF sensor/IAT sensor. Then verify the repair. If the TA side needs to be checked, turn the ignition OFF. Jump the SCS line with the HDS, then disconnect PCM connector B, the 51P connector. Check continuity on the TA circuit between the MAF sensor/IAT sensor 5P connector No. 4 YEL wire and PCM connector B No. 51 YEL wire. If you have continuity, the TA wire is okay. Update the PCM if it does not have the latest software, or substitute a known good PCM. Then verify the repair. If there is no continuity, repair the open in the TA wire between PCM B51 and the MAF sensor/IAT sensor. Then verify the repair. Keep verification separate from the circuit testing. Turn the ignition OFF, reconnect all connectors, and exit SCS mode with the HDS. Turn the ignition on, reset the PCM with the HDS, and do the PCM idle learn procedure. Then check for pending or confirmed DTCs with the HDS and look specifically for P0113. If P0113 is still indicated, go back to poor connections or loose terminals at the MAF sensor/IAT sensor and the PCM. If PCM updating or substitution was part of the path, pause, recheck the earlier diagnostic path and avoid guessing. If P0113 is not indicated, troubleshooting is complete. If a PCM was substituted and the fault is gone, replace the original PCM. If other pending or confirmed DTCs are present, check what they mean first. The clean way through P0113 is to prove the high IAT voltage first. Use the jumper test to separate the sensor from the circuit. Then check TA and SG2 for opens before making any PCM decision. For more diagnostic training, visit Diagnostics. Com.